Alright guys, today we're going to finish up with operations of polynomials. And all we're really going to do is look at some types of word problems or like different types of problems we have. Okay? So looking at example 5, and it says, explain what polynomial should be added to x squared minus 4x plus 6 to make the sum equivalent to 6x squared plus 3x. So this is just like what we were doing with adding polynomials. We have that box, right? 3 by 3. We have our first polynomial, right? X squared minus 4x plus 6. Right, so it gives us our first polynomial, minus 4x plus 6. And then the sum, where it says sum, that actually means your answer. Okay? So this is our final answer. Right, so my final answer, my bottom one, is 6x squared plus 3x. Okay, so I want to know how to get from this, my first one, to my last one. What should my second one be to make that jump? Okay, and sometimes they're a little bit easier to see than others. Okay, so x squared plus what is 6x squared, right? Well, if I'm going from 1 to 6, I'm going up 5x squared. If I'm going from negative 4 to 3, sometimes it's easier to draw a number line. Alright, if I'm at negative 4, negative 3, negative 2, negative 4, 1, 2, 3. Right? How many jumps do I have to make to get from negative 4 to 3? Right, 1, 2, 3, 4, 5, 6, 7. Right, I had to make 7 jumps. If you can do it without drawing the number line, that's fine. So if you're having trouble seeing, okay, so I'm going from negative 4 to 3, it's over up positive 7. Right? Sometimes making that number line and just counting your jumps is a really helpful way. And then for our last one, really I'm going from 6 to 0. Right? I have 6 is circle 3x plus nothing. Right? So in order to go from positive 6, right, to 0, right? If I'm starting at 6, I want to get to 0, I'm going 1, 2, 3, 4, 5, 6. That gets me to 0. Right? So I have to go back 6. Right? So 5x squared plus 7x minus 6. And so that's what I get for my answer. 5x squared plus 7x minus 6. It's that missing polynomial in the middle. 5x squared plus 7x minus 6. That's my missing polynomial. Alright, let's look at example 6, right? Same type of thing. I'm going to draw in that box. Three by 3, right? And again, this is always my x squared column, this is my x column, and that's just my number column, okay? So, what polynomial should be added to 2x squared minus 6x plus 5? That's my first polynomial. And then I want to get 2x squared plus x minus 1. Okay. And really, this is 1x, right? So if you just have ever of x, it's really helpful to put that 1 in. Alright, so what makes this? Well, in order to go from 2x squared to 2x squared, right? Well, that's just 0x squared, right? Nothing's getting added to that. To go from negative 6 to 1, here, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, right? I'm going 1, 2, 3, 4, 5, 6, 7, so I have to get to positive 1. So I'm going plus 7x. Then, in order to get from 5 to negative 1, right, I'm actually going to draw another number line Make it easy on us. -1, 0, 1, 2, 3, 4, 5, right? I'm starting at 5, I'm going 1, 2, 3, 4, 5, 6, right? So I went backwards 6, so -6, right? So really the polynomial I added to this, since this is 0x squared, I don't have to write anything about that, right? That's just 0, it doesn't count, nothing, right? So really we added 7x minus 6. Alright, let's look at example 7. Example 7 takes us into multiplying. Anytime you're finding area, most of our multiplication problems have to do with area. Right? Anytime you're doing area, you're going to be multiplying. Okay? So this says you are making square invitations for a party. You start with a square piece of paper with 8-inch sides. You reduce both its length and its width by x. Okay? So here's my square piece of paper. Okay. The total length of both of these sides is 8. Okay? It's an 8 by 8 piece of paper. It's square. I reduce both its length and its width by x. What that means is I'm taking scissors to it. Right? I'm going to cut this much of my page off. Right? On both sides. Okay? So now, all that's left is this side. I've cut off the rest of it. All that white part I've cut off. So if we were to reduce our page, I'm going to kind of show how this works. If I was to reduce my page by 1, so we're going to do x is one side of the table and length as the other side of the table. Okay, so if I were to reduce, if I were going to cut 1 inch off of both of these, right, then my side would be 8 minus 1, right, or 7. That makes sense. If I was to cut off 2 inches, then I'd go, oh, well, that would be 8 minus 2. I would only have 6 inches. If I were to cut off 3 inches, I would have 8 minus 3. Oh, that would be 5 inches. If I were to cut off x inches, it's the same type of thing. I would just have 8 minus x. Okay? So, this rectangle, or this square here, has a side of 8 minus x and 8 minus x. Both of those sides are 8 minus x because I cut x off. Right, so it says here, my area equals length times width. That's the area of a square or a rectangle. So I have 8 minus x times 8 minus x. So then we're doing the same thing we've been doing with multiplying. We create that 2 by 2 box. I have 8 minus x on top, 8 minus x on the side. So 8 times 8 is 64. 8 times negative x is negative 8x. 8 times negative x is negative 8x. And negative x times negative x is negative x squared. Yeah. So we can combine like terms. I have a negative 8x and a negative 8x. So I have 64, right? Negative 8x and negative 8x is negative 16x. Negative x and negative x is positive x squared. Sorry. So 64 minus 16x plus x squared is my final answer there. 64 minus 16x plus x squared. Okay. All right, let's look at one more example, our last example here, example 8. You are trying to fit a picture into a picture frame, but the picture is too big. You start with a picture that is 5 inches by 7 inches. Okay, so again, here's my pretty little picture. 5 inches here, 7 inches here. You reduce both its length and its width by x. So I'm taking off x on both its length and its width. So I just cut this part out. So I'm only left with here. Okay. Just like our last problem, right? Now that I've cut off x, I'm looking at just this rectangle. And that's 5 minus x and 7 minus x. Okay? So the area, once again, is going to equal the length times the width. So I create that box, just like we always do for multiplication problems. And I'm doing 5 minus x and 7 minus x. So same type of thing. 7 times 5 is 35. 7 times negative x is minus 7x. 5 times negative x is negative 5x. And negative x times a negative x is a positive x squared, right? A negative times a negative is a positive. So then, I do have like terms here, so make sure you combine those. So I have 35 minus 12x plus x squared. So that's the expression for the area of this rectangle. All right, that's all we have for today. Have a wonderful evening. I will see you guys tomorrow.